Okay. All right. Now I'm gonna share my screen and hopefully a few more people will join, but this is a good group as well if it's a little smaller. All right. I'm gonna share and then I'm gonna get going. Okay. So once I start sharing, it's hard for me to see chat. So if people put things in the chat, if someone else can look at that and bring it up, that would be great. Okay. I'll put it in slideshow mode. All right. So welcome everyone to the first meeting of the fall for the N3 program, the first monthly meeting. It's great to see returning people from the summer. It's great to see some new people. So today we're going to focus a lot on just getting to know each other and what we want to cover this year. All right. Um, we're also going to have our illustrious principal investigator for N3, Dr. Lynn Kaminsky, who's a STEM educator, astrophysicist, a successful grant writer for NASA, Department of Education, and National Science Foundation, and a horseback riding enthusiast, among many, many other talents. And she'll be doing an Ask Me Anything, which can be about astrophysics, but it could also be about horses. I'm sure she'd be happy to talk about either. Then we're going to ask you for some feedback for the evaluation of the program, and then we'll say goodbye. All right. I wanted to let you know next month we're going to have one of our mentors from the summer, Dr. Anthony Campbell, come and speak at the meeting. And he's going to talk about remote sensing of coastal wetlands and global change. All right, and it's going to be the same times on a Wednesday. It's going to be October 29th. And then the next meeting after that is probably going to be on December 10th. We won't have uh, a November and December meeting because of the holidays. It's kind of hard to find times that work both of those months on a monthly basis. So it will probably be December 10th, but we'll send an email confirmation about that. All right. So, one thing we wanted to start with was getting to know each of you a little bit better. Some of you are some of our scholars, some of you have been interns for a while. Um, and we'd really like for this community to get to know each other better. So if you wouldn't mind putting in the chat or raising your hand, which I want to make sure I can, if I can see, I'm going to put the chat up here. Um, what inspired you to apply to N3? Because I think a lot of you have different interests, and I think it'd be nice for folks to talk about what led them to applying. So if you could put it in the chat, or you could raise your hand, but I'm trying to see, am I going to be able to see you raising your hand? If not, someone else can let me know and call on them. When I have the slideshow sharing it.
I don't see any chat answers coming in yet.
Okay. All
Oh,
right.
there we go. There's one.
Great. So Maxwell's answer, I wanted to apply my programming skills to a full computational research project about the environment. Do others have stories about what inspired you? Maxwell's mentor was very cool. And people can see Maxwell's um, project on the N3 site, internship site from 2025. Does anyone else want to add? Ali, love for space and astronomy, and wanted to develop further skills with a summer project research. My mentor was from the summer was someone who did a lecture I was very interested in last year. So that's great that you're not the only one. I think another person saw the
There's at
astrobiology.
least one other pair that I matched because the applicant intern specifically requested somebody.
Yeah,
Makes my job much easier
yeah, exactly.
trying to figure out the matches for sure.
Yeah. And I'm sure that I'm some of our mentors might be the presenters in the year to come as they were so great. Yeah, we did the matching process early so we could make sure everyone had a mentor that fit. Ethan, um, I'm super ambitious, I'm guessing that's what it is. And I always wanted to work for NASA or any space administration, and I have a super big idea for rocket and space travel. Great.
Cool.
All right. Kirill, I'm saying Kirill, but I might be saying it wrong. Let me know if I'm pronouncing it wrong. I have an interest in space and astrophysics for most of my life, and I've been neurodivergent for all of my life. So when I found out there's a NASA program for neurodivergent people, it seemed like a natural place to apply to. Great. Well, you have an astrophysicist here to ask questions of, so it's your lucky day. All right. So others can put things in the chat if you like, but I'm going to move on. Second question. We have a series of meetings coming up through May. So we really want to get your feedback on what NASA related topics are you most interested in learning about? And we'll definitely try to make an effort to find people that you'll be excited to hear from. So you can, again, raise your hand or just unmute or put it in the chat. More about climatology.
Yeah, I
We'd
like
like to
to
have,
get suggestions from people because then I can use those to go out and find our future speakers
yeah. So you'll like next month's Maxwell. That's
for
about
science talk.
global change, which I guess is what they're calling climate stuff now. Um, planetary science and terraforming. Nice. Black holes. I remember there was a monthly meeting about them, but I wasn't able to attend. Oh, well, this is why we record. I think all the monthly meetings from the past have been recorded. So, um, I just shared one with somebody a few weeks ago. Um, Dr. Javi, which was one of the mentors, talked a lot about college major plans that could include me studying CS and climatology, planetary science. Had a spectacular advice on that. Excited for that meeting. All right, any other topics that people are interested in? Oh, good. Solar science. Great. We definitely had some solar science experts who were mentors.
Well, and I hope people saw the news today, but NASA just launched 3 solar satellites, two of which we're sort of involved with at Sonoma State or colleagues of ours that work on N3 are
Yeah.
involved with Carruthers. and IMAP is the $1 billion Christmas tree satellite that has ornaments on it. Has
Ah.
10 like 10 different experiments on it. Those satellites are called Christmas trees when they try to do everything for everybody. And it's the parent mission of a small CubeSat that my undergrads have been building at Sonoma State. So our CubeSat is looking at launching in another 2 months with any luck.
Great. All right. Well, please provide us feedback on what you're interested in, okay? Because we want to make sure we find things that are of interest to you.
And
And,
Ali, we probably taped that show about black holes, so feel free to look at the stuff on the website. You can probably see a recording of that black hole talk.
all right. And third, we also often cover things besides NASA science topics. Sometimes we cover topics to support neurodivergent learners on the career and academic pathways that you want to focus on. So, some of the things that we've covered in the past include time management and scheduling, self-advocacy and accessing accommodations in college, initiating tasks and getting over some procrastination you might be feeling, um, college and career preparation. I think Maxwell mentioned that. Um, and then maybe learning from the other N3 interns about their projects or academic paths. We have people who've been doing this for 5 years now, so um, we could probably try to ask one of our former interns to talk about what they did and where they're going. And that would really probably be very helpful for people who are just starting on the path. So if you wouldn't mind putting in, okay, oops, some people have already started. Um, and Maxwell mentioned self-advocacy, especially the idea of living alone and living life as a neurodivergent individual is something I'd love to cover. That's great. Previous interns come back and talk about the project. Or Maxwell, possibly you could talk about your project. And Ali, self-advocacy. I think self-advocacy is on the list for next what month. Um, Great. We'd love to have Maxwell come. Self-advocacy and also career preparation, cover letter and resume. Yeah. Yep. I think we definitely have.
Yeah, I think we might have had one about that before,
Mm-hmm.
but that was a different group of people, so we could do it
Yeah.
again.
All right. Anyone else um have things about, taking next steps? We definitely, we're building such a good community of neurodivergent science majors that I think having a group chat about that would be pretty useful. All right. Well, I want to give you lots of time to talk with our astrophysicist and horseback riding enthusiast, Lynn. Oh, I wanted to do one more thing, which was these are what we're thinking will be the likely dates going forward. Um, just to give you a sense. So for sure the 29th, likely the 10th, and then if we continue after that with the kind of third week in each month, this would be what we do. If we have speakers who can't make those dates and need to do the following Wednesday, then we would accommodate their schedule just to make sure we can get those speakers. But this is what we're aiming for. So that it's about a month apart. All right, so we're going to move on to our Ask Me Anything session. So obviously, this is a question and answer. Um, and if you have a question, you should enter it in the chat or use the hand function, okay? And we'll go in order of the questions. Uh,
Okay, so as some of you may know, I've been a professor at Sonoma State University for almost 40 years. I actually just retired to half time, which is interesting. So I'm trying to keep all my Zooms to Mondays and Wednesdays.
oh,
Um, I've been doing research in high energy astrophysics, which means I study black holes and neutron stars for pretty much my entire scientific career. And then I got involved in the whole STEM education business, which is what created Edion, although the Edion is just the newer name for the group. The group that I started in 1999. So I've had people being paid by grants to do STEM education and outreach in the different programs that I've thought of and gotten funding for since 1999. And that includes working on the Swift satellite, the Fermi satellite, LIGO. I was part of the team that discovered gravitational waves in 2015. And then I've done all sorts of rocketry and hands-on projects involving rockets and small payloads. And then that turned into CubeSats. So my undergraduates at Sonoma State are now building their third CubeSat under the leadership of Laura Pedicolis, who's taking over Edion now that I've half retired. So any of those topics are fair game, or my little horsies or my big horsies are okay too. I just figured I would amuse you with a picture of my two miniature horses. Peggy Sue is the one on the left, and Jet is the one on the right. They are about 3 feet, about 2.5 feet tall. So, any questions about, astrophysics, rocket science, the N3 program, whatever? If you don't want to ask them out loud, just type them in the chat or raise your hand. Okay, Ethan.
All right, so number one, I see that you went to MIT
I did
school.
for my PhD.
Yeah, like I've been looking into NASA and they always want people generally with PhDs or something like that. I've looked into it. And right now I'm going for associates in mechanical engineering at Cape Fear Community College down in North Carolina.
Okay,
But
good
I
start.
have this really crazy idea, might be too extreme for NASA, but on you know the shuttle boosters,
Yes.
basically making a version of those that are reusable.
Okay, so you're talking about the reusable things that take things from the shuttle up into higher orbits?
No,
The shuttle itself, you mean the rocket
the solid
boosters
rocket
that,
boosters.
yeah. Well,
Those I want to make.
we don't launch the shuttle anymore.
Yeah, I know, but I'm saying like
Right.
basically
So,
taking one
and
of those.
But what SpaceX has done is basically sort of pioneer reusable rocket booster parts. So,
Yeah,
so they're doing that. And a degree in mechanical engineering is a great degree if you want to work for a company like SpaceX in the future, right? So
yeah.
you can work for NASA by working for NASA contractors, that are building things for NASA.
Oh, well,
It's pretty much the same thing, right? Because
yeah.
Is
Because
now contracting out a lot of the things that they're building. So another press release that came out today, actually. So my Swift satellite, which is the Niels Gerald Swift Observatory, looks for gamma ray bursts, and it was launched 20 years ago in November of last year. So it's 20 years and a half of a year since then. It was launched November 20th, 2004. So things that are in a low Earth orbit, when the sun gets really active, like it's currently doing, this is 2025 is a solar maximum year, the atmosphere around the Earth gets puffed up because it gets heated by all the extra particles coming off the sun.
yeah,
So
like
If you had a satellite,
The Carrington event.
which event, Carrington?
Yeah, that Carrington event. I was looking into like how Earth's magnetic field and all of that. I've
Yeah,
done a lot
yeah,
of
that was a
research.
magnetic event. I'm just talking about plain old atmosphere expanding. So if you had a
Oh,
satellite and it was going like above the atmosphere, and now the atmosphere expands, now the satellite's flying through the atmosphere, it's getting a lot of drag on it, and it's gonna make its orbit decay and make the satellite
eventually
a
fall out of
lot
the sky.
faster, right?
Hmm.
Okay, and so they just today put out a press release that they've hired a company that hasn't ever done it before. No one's done this before to make a booster for Swift. It's going to go up there. It has a platform and these three robot arms. It's going to grab Swift and it has rockets on it and it's going to boost it up to a higher orbit so that it doesn't decay so fast and come back in. So
Oh,
that's
that's
so
cool.
yeah, it's really sort of cool. The press release just came out for that today, and that was
Yeah, like so.
a satellite I've been working on since the late 1990s, long before all of you all were born. I've been working on this satellite and it's still producing amazing science. So it's really great to know that NASA
Yeah,
wants to try to save it.
yeah.
Okay,
I
so
learned.
you could mute yourself now, Ethan, and then I'll answer a question from somebody else
Right.
if somebody has a question. No one's curious about the cosmos tonight. There we go. All right, Sam wants to know something. That's fair game. Okay. Sam wants to know more about my college and grad school experience. What would I say my strengths and challenges were in school? Well, I had sort of an unusual background because, I'm really old and computers really were just beginning to be invented when I was in college. That may seem really strange to all of you because you've all grown up with smartphones in your pockets. But um, when I was in college, I was one of the first people to ever take a class to learn about computer programming. They had just got their first computer. It was a big mainframe. And I ended up getting a job working on the mainframe because I certainly didn't learn anything about computers in the class that I took. And I asked one of the TAs, well, how do you actually learn about computers? And they said, oh, just get a job at the computer center. So I did. And since hardly anybody even knew what I knew, and I didn't really know anything, but I at least took this class, they hired me. And that was when I finally figured out how computers worked. Just sort of sitting there and typing commands and tearing off people's output printouts and mounting magnetic tapes for people. But, it's just sort of by osmosis. I figured all of a sudden I could just do anything with computers. So the problem is that back then there were no computer science departments because they were just inventing the field. And so all of the only things that had to do with computers were in the physics department. And I was actually studying chemistry. So, and I was doing chemistry research every summer, but I didn't particularly like it because I wasn't very good at it. And I would work like all day making some solution, for this experiment we were running, and then I'd spill it at the end of the day, or something bad would happen to it. And I just decided I was far too klutzy to be a chemist. I had many pairs of blue jeans with acid holes all the way down the front. Before that was cool. Um, so then I got to computers, and then it turns out if you make a mistake, you could just fix your program and keep going. And that was much more suitable for the way that I like to work. So I definitely wanted to do some computer things. And then I graduated from college with it ended up that I took a couple more physics classes and it ended up with a double major on paper in physics and chemistry. But really, I was a chemist that knew a lot of computer stuff. So then I went and applied for jobs after college because I didn't know what I wanted to do. And I applied to chemistry jobs and I applied to computer jobs. And the job that I got was a computer job, turned out to be at the Harvard Smithsonian Center for Astrophysics in Cambridge, Massachusetts. And it was analyzing data from the very first X-ray astronomy satellite. So that was really that was a fun job. They paid me to take a bunch of heavy boxes of printouts and punch cards and tapes on an airplane down to NASA Goddard in Maryland. 35 weekends in the next 2.5 years where I ran all these batch jobs on these huge mainframes they had at Goddard and then flew home with all the boxes of output. And in between, while the batch jobs were all running, I would go out and visit all the museums in Washington, D.C. So that was an interesting job to have. But while I was doing that work, I learned about X-ray astronomy and in particular about the discovery of the first black hole, Cygnus X1, that was made possible by the satellite whose data I was working on. And so I was like, wow, this is cool. I love science fiction. I've read lots of books about black holes. Someone actually wants to pay me to study black holes for a living. So when it turned out it was time to go back to graduate school, I had written 4 papers with the data from that satellite, Uhuru, and decided I would finally learn physics because everyone that I looked at, like Ethan was saying, you look and see where people have degrees that are doing what you want, and they were all from MIT. So I'm like, okay, I should go to MIT and learn physics, and it was just down the street from Harvard anyway. So then I went to MIT and learned physics, but that was really hard since I didn't actually really know any physics. I had a lot to learn in a very short period of time, and I had to study a lot and do a lot of practice tests and a lot of practice homeworks and a lot of practice qualifying exam questions, and it was basically very hard, but I was able to do it, and I wrote my thesis and got married and moved to California. So, and there are many other little stories. Computational climatology would be a good choice. I'm looking at Maxwell's comment. Yeah. So I always knew that I would go to some other school after college, but I didn't know. My parents wanted me to be a medical doctor. I've been a squeamish vegetarian since I was 16, so the blood and guts of medical school did not really appeal to me. Also, the heavy debt load you'd have to take on. So the great thing about going to grad school in a physical science like physics or chemistry is they pay you. You don't pay them. So you don't end up in debt. If you change your mind, you're not out of pocket. So, but so then there's like, should you get a PhD? A lot of what Maxwell's writing about is, you know, should you get a PhD? And a lot of people say, well, maybe a master's is good enough. Well, that just depends on your field. So with physics in particular, or astronomy, or chemistry, and for most biology, a PhD is what you need to get if you want to be a professor or if you actually want to lead your own research in the field. If you want to be an engineer, most engineers do not get PhDs. Most engineers get master's degrees if they want to get an advanced degree. If you get a PhD in engineering, what that does for you is you could be an engineering professor. You could do research in engineering as opposed to the practice of engineering, like actually physically designing things for somebody else's project, right? So physicists work very closely with engineers because the physicist has a crazy idea for, what they want to achieve scientifically, and the engineer is the person that figures out how to actually make those measurements and build that thing. With a PhD in engineering, then you're sort of doing research into new ways of doing engineering, if you see what I'm saying, as opposed to actually just designing things and building things. So, so that's a little bit of a difference. In the state of California, if you get a master's degree in, say, physics, you can teach community college, but you can't really teach at a place like Sonoma State. That requires a PhD to have a tenure track job at a 4-year university or a research university.
Maxwell also mentioned the education piece, and I think it's really interesting that like when you do become a PhD, you often need to teach, right? But like you've gone beyond that. You're not just teaching grad students and undergraduates, you're developing programs about STEM education. Can you speak a little more about that and how you ended up there?
Yeah, so then when I came to Sonoma State, which is a teaching focused institution, I had always been at research institutions like Harvard and MIT, and my undergraduate at Brandeis, which is sort of like the Jewish Harvard, as people call it. So yes, nobody teaches you how to teach, and I was never a teaching assistant. Even in grad school, I had research support money. So a lot of people first learn how to teach when they were teaching assistant in grad school, but I never was one. So I never even did any teaching until after I was a postdoc at Berkeley. And the professor that I was working with there didn't want to go give a talk at Sonoma State, so he sent me. And then I met all those people, and they asked me to come teach a class there, and I had a blast. I just loved it. So I thought, oh, well, this is fun. And then they wanted me to do more part-time teaching, but I had a full-time job at Berkeley. I was running part of a different satellite project called Extreme Ultraviolet Explorer, and was going to get launched in a year. So I was like, well, if you have a tenure track job, let me know. And a few years later, they did. So they reached out to me again, and I said, well, my satellite's about to be launched, and I've been working on it for 3 years. So I'm, probably I'll apply because I know you need women to apply, but I'm going to work on my satellite. And then the shuttle blew up. The satellite was supposed to go on the shuttle. The satellite launch got delayed for 6 years or longer. They had to redesign the entire satellite to be launched on a Delta rocket. And I got tenure at Sonoma State before the satellite ever got launched. That's how long of a delay it was. So, yeah. So, Elise question, how do you know if you truly want to do research? Well, I thought I did, right? I did a lot of research. I'm an author on over 200 papers in peer-reviewed publications, but in the beginning, a lot of those I was the first author on, and I was leading the research effort. I wasn't just part of these big teams from these satellites or from LIGO. And, I was pretty good at doing research. I made a couple of discoveries that I'm really proud of. But I was really great at being a teacher. I was way better at being a teacher than I was as a researcher. Like, I knew I would never win a Nobel Prize, but I was pretty sure I could win a whole bunch of teaching awards, which I subsequently won. So the idea of being a professor appealed to me. The exact balance of teaching versus research was not something that I was all that consciously aware of at the time. I mean, I really thought I was just going to be this gung-ho research person because everyone wants women to teach, right? And men to do research. And that was what society was pushing, right? And I was like, well, no, I'm a woman. I have to do research because I have to, show that I can do it. But then, then I thought, but I really like teaching. I'm a lot better at teaching, it just brings me great joy. So sometimes you just have to follow the stuff in your life that is what brings you the most happiness. So I ended up bringing in money, buying off some of my teaching time, trying to have a balance between research and teaching that was a little bit more balanced. At a research university, you'll be doing like 80% research and teach one class. At a place like Sonoma State, you'll be doing like teaching 4 classes, and you're lucky if you have even 10 or 20% of your time to do research because you're teaching so much. And so by buying off some classes, I was able to have it be like 50-50 for a while. But then I started getting so much grant money that I ended up basically buying off all of my teaching time. So for the past 20 years, I haven't really taught any classes at Sonoma State except as an emergency. Like if somebody couldn't teach something one semester, I'd hop in and do that. Instead, I've been teaching teachers, and I've been writing curriculum for high school students to teach them how to use sensors and write computer programs and make measurements and analyze data and learn cosmology. I mean, I've done a whole bunch of curriculum development projects. You can see them all on the Edion website. It has links to all of our different projects. So yeah, I found it a lot more fulfilling to basically be explaining to other people how I think things should be taught. And thinking of things like, oh, NASA doesn't have a program for neurodivergent students. I think I'll create that. Like seeing a need to try to include everybody and to try to reach everybody, whether that's teaching 8th grade girls how to solder jiggy bots or the N3 intern program or whatever. I just, teaching middle school kids how to build payloads for rockets. But, I like to do hands-on stuff, and I like to teach other people how to do hands-on stuff because I think it's very empowering, not just software. It's great to be able to do software and simulations. My PhD thesis was I used a big code and did a bunch of theoretical simulations of neutron stars blowing up. But I just, I felt a lot more balanced and capable and empowered once I started being able to do hardware too. Makes a big difference. People that know how to program but also understand the hardware of the thing that they're programming, those are the best jobs to get. if you're, so inclined into an engineering kind of thing. So yeah, and of course the other thing that appealed to me about being a professor was the schedule. I learned when I had the job in between college and grad school that I am not a 9 to 5 kind of person. It's really, really hard for me to keep a 9 to 5 schedule. I wanted a job where I could be in charge of my own schedule and I didn't have to work in the summers if I didn't want to. Of course, I've worked every summer, but
I was
and I
going to
work
say,
all the
then you
time.
work
I
constantly.
just don't work 9 to 5. I'm just really bad at a fixed schedule. I'm not bad at working hard. I'm just bad at a fixed schedule. So that's a good thing about being a professor. All right. Any more questions from anybody? Rather
And
quiet group.
astrophysics, black holes, anything? I know Lynn knows about black holes.
It's true. I think, let's see, the most recent public talk I gave was called The Universe Is Never Seen Before. As part of this series called Professors and Pints, where professors go to bars and give talks to people who pay money to buy tickets to hear them talk about things. So I just did that a couple weeks ago. That was a very interesting experience. I've given science cafe talks before, but this one was sort of outdoors. You can't see slides that well when you're speaking in a room that's got all these windows and sort of a fake roof. It's sort of like it's like a beer garden kind of place, I guess.
Ethan has a question. Do you think it's possible for a red dwarf to have a planet like Earth?
Okay, so like orbiting around it? Sure. I think first of all, there's a lot more red dwarfs than there are yellow dwarfs like the sun. Red dwarfs are pretty much the most common and boring star that you have in our galaxy. So they're like a little smaller than our sun, and so they're cooler, right? So if you have a cooler star, then that makes a habitable zone be closer into the star than it would be around the sun. Okay, so there's definitely a possibility for Earth-like planets around a red dwarf. And for them to be the right conditions habitability wise, just because there's a nice sized habitable zone around a red dwarf. Also, they last a really long time. The smaller stars live so much longer than the bigger stars, right? Our sun will last 5 billion years. Another 5 billion years. It's already been here for 5 billion years. Our sun's total lifetime is 10 billion years. But the red dwarfs, because they're smaller and they burn slower, they last even longer. So that gives plenty of time for life to evolve. And as you know, as Carl Sagan's famous quote goes, if there's not life out there somewhere, that would be a tremendous waste of space. And people often ask me if I think there are aliens out there, if I think the aliens have contacted us, that kind of thing. And yes, I think there are aliens out there, and no, I do not think they've contacted us. Okay, so why do I think that? If anybody ever saw the movie Contact with Jodie Foster and the radio telescopes, there's one scene where all of a sudden they're showing Hitler giving a speech. And then a whole bunch of other stuff sort of streams by. If you remember the Hitler part, it's sort of striking. Why did they show Hitler in that movie? Because that speech that he gave in 1936 was the first time we really sent strong radio signals out from our planet. Right? Radio waves are a form of light. They travel at the speed of light. 1936 to 2025 is like 90 years. That means that stars that are within 90 light years of us can have received those signals and would know that we were here if they were a radio listening technology. But that's all. Now, how many stars do you think there are in, a radius of 90 light years around the Earth? Of the 100 billion stars in our galaxy, how many of them do you think are within 90 light years of us? Guesses out there? All right, well, I'll let you ponder that. Okay, somebody guessed. Wendy guessed too. 100, yeah, 100's a pretty good guess. No, a couple 100,000, absolutely not. No, just 90 light years is not very far. It's 10,000 light years to the center of our galaxy, right? 90 is not very far at all. So there's about 100 stars. Good guess, Carol. So they're the only ones, if they had planets around them and those planets had life, those are the only ones that would know that we're here. No, none of the other stars in our galaxy would have seen that signal from Hitler's speech yet, because they're all further away than 90 light years. So nobody would have any idea there was an intelligent civilization on our planet. So they wouldn't know to look for us. Similarly, we wouldn't know to look for them if they're in a similar state of technology and they're at the other side of the galaxy. We wouldn't have heard from them yet. Right? So, yeah, but there's so many stars and there's so many galaxies. There's got to be something out there that has developed, but it's not going to be anywhere where we could have heard from it because space is just too big. And space is also mostly space, not planets and stars. So, yes, well, those are popular questions that I get asked a lot when I'm out in the community. Okay, one thing I can't believe is Betelgeuse. Yeah, it is supposed to go supernova soon, but soon on an astronomical time scale, right? So it could be only a mere 10,000 years from now. Even if it was only 1,000 years from now, none of us are going to see it. And trying to predict that something is going to happen in a time scale of years in an astronomy thing is sort of risky. Now, there's another star out there that they think might be going supernova even faster. It's called T Core B, something like that. That's one I've been reading about lately that people think is going to go supernova even before Betelgeuse. So I have a student, Christopher, actually, that has been watching that one. He's trying to get some data with a bigger telescope to see if he can get lucky, get observing time for the night it decides to explode. That will probably never happen, but it's still a fun project. All right. Well, not a
Ethan's
lot of
asking
questions.
about Antares. Is that
Oh, Antares. Yeah, that's another star. Yeah. Well, there's a few likely candidates for what might happen, but it's still astronomical timescales are very long compared to the length of time people have lived on Earth or the length of time that recorded history has happened on Earth, which is only, maybe 6,000 years or something. Maybe 7,000 if you stretch it a little bit. That's just a blink of an eye for a star. Okay, well, I think we might as well do the questions, the evaluation questions here at the end, since nobody is terribly curious tonight.
all right? So
I'll be
I'm
back
planning
with astronomy talk next month. So I mean, Earth science talk.
Earth science. Yeah. All right, I'm going to share my screen. And Josh, I don't know if you wanted to give a little bit of a introduction to the evaluation.
Yeah, sure thing. Thanks, Wendy. So, my name is Josh. I'm with WestEd, and we're the external evaluators 4 and 3. So, our job is to help collect feedback for continual improvement of the program to give you all a better experience and a better experience for any future participants in the program, and to help document what sort of impact the program is having for you all. So, we've just got a couple of questions that we'd like to get your feedback on. If you could just put it in the chat. Again, the purpose is to help us understand what you all want future support on. We really want to emphasize there's no right or wrong answers. We're purely asking for your opinion. And we'll have just 4 questions for you. We'll spend about 60 to 90 seconds of them on each of them. So again, just put your feedback in the chat. That way we can make sure we capture it all. and let us know what you have to say. Thanks, Wendy.
All right, so I'm gonna go quick to this first question. So again, if you can put things in the chat, what takeaways are you leaving this meeting with? So if each of you could write like one takeaway you're leaving the meeting with, that would be great in the chat. Mm-hmm. That's good, Ethan. Mm-hmm. Great. Yes. Thanks, Maxwell. Anyone else? Yeah. Yeah. That's good. Professor might be an ADHD friendly career. I think you're right. Yeah, a lot we don't know about black holes. That's true. All right, I'm going to go to the next question. What good things happened in the meeting today? Learning about space. A knowledgeable answerer of questions. Yeah. Yeah. Lynn has a lot of experience and has a lot to say about space and becoming a scientist and an educator. All right, I'm going to go to the next question. What should we do differently next time? So we always try to make the meetings better each time based on what people want. Okay. All right. And then the last question, what did you want to happen but didn't happen today? Ah, okay. Right, because Ali, you're on the West Coast now, right? That's right. How's college? Good? Good. All right. Well, I'm going to stop the share and say thank you so much for everyone for participating, and especially thank you to our fearless leader, Lynn Kaminsky, for every time I hear you talking, I learn new things, and I've been working with you for 5 years or 6 years with the proposal. So,
Okay, well, with any luck, we'll be able to keep working together for another 5 years, but
yeah,
it sort
exactly.
of depends on the government.
Yeah,
So
exactly.
I guess we'll see. So yes, everybody stay tuned.
Yeah,
We hope to continue past May.
yeah. All right. Well, thank you so much, everyone, and enjoy the rest of your evening.
We'll see you next month. Bye.
Bye.